everyone. Here is a video for solving and graphing polynomial equations number 5. I'm actually not going to work number 1. I'm going to skip down to number 2 because it has probably what I would consider to be the most amount of work. Number 2 and number 4 are about this way, just so you can see a problem being worked all the way through. So I'm going to skip number 1 and go on to number 2. Okay, so on number 2, we have solve and sketch a graph of f of x equals x cubed plus x squared minus 10x plus 8. We're going to go through all of the steps of finding the possible rational roots, Descartes' chart of signs, factoring, solving for all of our roots, and then graphing. So I'm going to start out by doing Descartes' rule of signs chart, and I look at the signs of what I've been given. I've got plus, this is positive, positive, this is negative, and positive. There are 2 sign changes, so that tells me there are either 2 or 0 positive real roots. Then I will look at f of negative x, and when I plug in that negative x, I'll look at those signs. And so this first thing, a negative to an odd power is negative, a negative to an even power is positive, negative times a negative is positive, and then the last sign is positive. So we only have 1 sign change, so that means we only have 1 negative real root. So I'm going to make my rule of signs chart over here. So I've got positive, negative, and complex or imaginary. I know I'll either have 2 or 0 positive real roots, but I need to combine each of the positive real roots with each of the negative. But there's only 1 negative, so I'll have 2 with 1 and 0 with 1. Each row has to add up to the total number of roots or solutions that we have, which by looking at the degree we know we will have 3 roots, so each row has to add up to 3. So 2 plus 1 is 3, so that leaves none for the complex or imaginary, and 0 plus 1 is just 1, so that leaves 2 for complex or imaginary. So there's our signs, our rule of signs chart. Now let's look at the possible rational roots, and that's the p over q values. So first we'll figure out what the values for p are, and those are the factors of our constant term 8. So that'll be plus or minus 1, plus or minus 2, I've got 4, and also 8. For my values for q, those are the factors of my leading coefficient, which here is just 1, so that's plus or minus 1. So my p over q values are each of my p values divided by each of my q values. I only have 1 q value, so plus or minus 1, plus or minus 2, 4, and 8. Okay. Now that we have some possible rational roots, and we know about the breakdown of the possibilities for our real roots and imaginary roots, let's look for solutions for this function. You always want to check to make sure that if this factors, you could save yourself some time, but factoring by grouping here will not work. So what we need to do is start picking values from our list of numbers here, and we can use those to use synthetic division. So I'm going to look over here at my list of possible roots, and I know that no matter what, I'll only end up with 1 negative root. I could have 0, or I could have 2 positive real roots. So what I'll do is I'll look for my negative root, and it's really up to you as to which way you want to do that. It's just a strategy I chose. So I'll start out by looking at negative 1. Oops, negative 1. And then my signs for my coefficients for this polynomial are 1, 1, negative 10, and 8. So I'll bring down the first term, multiply it times negative 1, and then add, times negative 1, add, times negative 1, add. Okay, so that does not add, my last number is not 0, so that tells me the negative 1 is not a root. So let's try a different number. How about we try negative 2? So I'll bring down the first term, multiply it, and add, multiply, add, multiply, add. Again, that does not add up to 0, So we'll try the next negative number, which will be -4. So bring down the first term, multiply, and you get -4, add -3 times -4 is 12, add, you get 2 times -4 is -8, add, you get 0. So there we go. We have found out that the -4 works. We have found our only negative root. So now that we know we have -4, we can use that information because this right here, what we found so far is we have x plus 4, since we know that -4 is a root. It's the opposite sign. And then this down here, what was left over, is what we have left over after we factored out the x plus 4. So we had an x cubed, so this is 1x squared minus 3x plus 2. And we look at that and we say, okay, does that thing factor? Is there anything that multiplies to 2 but adds to -3? And there are two numbers that do that, and they are x minus 2 and x minus 1. -2 and -1 multiply to +2 but add to -3. Therefore, all of the roots, we have found them. We have -4, we have 2, and we have 1. So we had 1 negative and 2 positive, so it turned out that we had that first row in our Descartes' rule of sign charts. Okay, so the x-intercepts, the reason that it seems a little redundant, but it's actually being very specific here. We're not just looking at the solutions, which could possibly include imaginary solutions. Now let's look at the x-intercepts. X-intercepts will not include imaginary numbers because on our xy plane, they're only real numbers. So our x-intercepts are at -4, 0, 2, 0, and 1, 0. Our y-intercept is our constant term of 8, so we have 0, 8. And then for the end behavior, we're trying to figure out, first of all, what is y approaching as x approaches -infinity? And then we'll want to figure out the same thing for whenever x is approaching +infinity. Well, the +infinity, that will be the right side. So looking at the leading coefficient, it's positive, so that means the right side is going up. So the y values are approaching +infinity. But since our degree is odd, the left side will do the opposite of the right. So the f of x will approach -infinity as x is getting really small, which is on the left side. So let's go ahead and plot these points. So we have 1, 2, 3, -4, 0, 2, 0, and 1, 0. The right side is going up. The left side will be going down. Oh, I guess we should also put our y-intercept. There we go. Okay, we don't have a multiplicity of any of our roots, so we just go through each of the points from left to right. There we go. Let's look at one more problem like number 2, and that's number 4. So again, I'm going to start out by looking at the signs of the original equation. This is positive, then negative, negative, positive, and negative. So how many sign changes are there? Well, we've got 1, 2, 3. So we've either got 3 or, remember we subtract 2 at a time, 1 positive real root. Then we look at the signs of f of negative x. Okay, so this first thing will be positive, and then a negative cubed is negative, but times that -2 is positive. This next thing, a negative squared is positive, but then -7, and then we'll have a negative and then negative. So we only have one sign change. That means we have one negative real root. Let's make Descartes' rule of signs chart. So we've got positive, negative, complex, or imaginary. So we have 3 or 1 positive real roots, but we only have 1 possibility for the negatives. Each row here will add to 4 since our degree of our polynomial, our highest exponent, is 4. So we need to fill in the blanks of whatever gets us to 4. So 3 plus 1 is 4, so that means we're already there. 0 for complex or imaginary. And then we've already got 1 plus 1 is 2, so we still need 2 more to get the total of 4 solutions. So there's our chart. Now let's find the possible rational roots. So for the p-values, we're looking at the factors of our constant term of negative 12, so that'll be plus or minus 1. Plus or minus 2, 3, 4, 6, and 12. For Q, those are going to be the factors of our leading coefficient, which here's just 1, so it's plus or minus 1. So our P over Q values, I don't feel like rewriting them, are all of just the P values, because we take each P value divided by each Q value, but since it's only 1, these will be the same. So, okay. Okay, the next thing we want to do is take all of our possible rational roots, compare it with our chart here. Again, we only know that we will have 1 negative. So, since we will only have 1 negative, if I find my negative number, then I can ignore all the rest of the negative numbers. To save us a little time, I am going to let you know that it already will occur at negative 3, but just because of, I don't want to get this video too long, I don't want it to be too long, and I'm going to run out of space. First, I tried negative 1 using synthetic substitution with my polynomial. Did not work. Negative 2 did not work. But whenever I used negative 3, I'll show you that that one works to prove it to you in case you were doubting me. So we bring down the first term, multiply and add. Multiply, we get 15. Add, you get 8. 8 times negative 3 is negative 24. Plus 20 is negative 4. Negative 4 times negative 3 is 12. Plus negative 12 is 0. So the negative 3 works. And then, since I've already found my negative root, I'm now going to check the positive roots. Again, to save a little bit of time, I tried the positive one. It did not work. It did not give me a remainder of 0. However, when I got to the positive 2, what I ended up doing was taking the 1, negative 5, 8, and negative 4, and I used synthetic division on that. Bring down the first term, multiply, add. You get 2, 2 times 2 is 4, and 4 plus negative 4 is 0. So you can see here what we've got so far. I'm really running out of room here, so I'll go up to the top. Okay. My first factor I had, a negative 3 worked, so that's the factor x plus 3, opposite sign. Okay. This 2 right here that worked, that tells me that my factor is x minus 2. And then this line at the bottom here left over. So we had an x to the 4th to begin with. This would have been an x cubed, but then we divided out another factor, so this is x squared. So this is 1x squared minus 3x plus 2. And then I'll think, okay, does this thing factor? Because sure, you could keep using values synthetic division for that bottom line, but if it factors, it could save you a little bit of time. And this factors, so we'll have x plus 3 times x minus 2. And then what multiplies to positive 2 adds to negative 3? Well, that's negative 2 and negative 1. Therefore, all of our roots are listed right here, just the opposite sign. So our solutions will be at negative 3, positive 2, it'll happen 2 times, and then positive 1. So don't forget that that 2 right there will happen multiple times. Okay? So the x-intercepts will occur at negative 3, 0, 2, 0, and 1, 0. The y-intercept is our constant term, so that'll be at 0, negative 12. And then, just to save us a little time here, the end behavior of f of x on the right side it will go up because our leading coefficient is positive, and since it is an even degree of 4, the left side will do the same. It will also go up. So let me graph these x-intercepts. So -3, 2 will happen 2 times, and then 1. We've already figured out the right side will go up, and the left side will also go up. Our y-intercept is at 0, -12, which will be slightly off of our graph. That's okay. And then don't forget that the root at 2 has something special happening there, since it had the multiplicity of 2 there. It had an even multiplicity. So I'll go through these points. I go through the 1, but then whenever I turn back around, you'll see that that arrow is already there for the 2, and it's good because whenever it got back to the 2, it bounced back off of it and went up since it had an even multiplicity. And there's our graph. So for the rest of the problems on this worksheet, there are previous videos you can go back and watch. I will have the answer keys all posted before the test, just for your reference, and I will see you in class. Feel free to ask me any questions then. See you later. Bye.